Hello everyone, thank you very much for joining this live event. This is lesson number 9 from the Spring Security stream, and we discuss today cross-site request forgery, also known as CSRF. And we'll discuss about what the vulnerabilities in applications, what the attack is, of course, and about Spring Security and the Spring Security protection against CSRF. So let's start with an example already. By the way, if you are watching the event live, you can use the live chat to ask questions, and if you are watching the event recorded afterwards, you can still ask questions in the comment section below, or you can find me on LinkedIn or Twitter. You can follow me there and you can ask me questions, and I will answer you in a next video or in a separate video depending on your question. Let's start discussing CSRF, and let's see how does CSRF affect our applications, and how does Spring Security protect our applications against these kind of vulnerabilities. To do that, I will first start with an example, and then I will try to detail more and more on how CSRF protection can be configured in Spring Security. And this is a really important thing to understand, because CSRF is one of the vulnerabilities which was there on the OWASP top 10 for a long time, and that's why you still expect to see it in several applications, even though it was some kind of mitigated usually in frameworks or by the usage of frameworks such as Spring Security in the past years. But you still need to understand what CSRF is and how does it affect your application, so that you make sure you don't have such a vulnerability in your application. And let's start with a very simple web application, because that's where CSRF is actually encountered. And I will create a project using Spring Boot. And the only dependencies I actually need, well, this is Spring Security C9, of course, and we can use the latest and greatest version of Java, which is 14 at the moment. The only dependencies we need for our example now is the web dependency. I will create a very small web application to prove it, and because I will need a front end for it, to make it as simple as possible and allow you focus on the important things we discuss on Spring Security, I will use a TimeLeaf engine for developing the front end. It will help me spare some lines of code. So instead of focusing on things that are not related to the subject of discussion, using TimeLeaf will help me will actually help you allow you focus on the things we actually discuss in this lesson. So I will use this template engine because of that. And of course, security, we are discussing Spring Security, so yes, we need Spring Security, and these are the only things we need for our today's topic. So let's go on with these dependencies, and I will simply just now create my project and develop a very small web page for our example that of course is available under a login form. But fortunately, the login form, I will use the login form provided by Spring Security, so I don't have to implement that as well. I only have to rely on Spring Security for that. So the only thing I actually do need to implement here is controller. So let's create a controllers package, and inside the controllers package, the main controller, which is the only controller of my application. And this will be a normal controller again, because what I want to create is a web page. So in this case, for this application, I will rely on TimeLeaf, and I will create a simple web page and not some REST endpoints as you got used to from our previous lessons. But that doesn't mean that what we discuss here doesn't apply to the REST endpoints. It does apply in the same way to the REST endpoints, just that using REST endpoints it would be much more difficult for me to explain you what CSRF is and how the protection for that works in Spring Security. So that's why I've chosen for this example to use a normal web application and not some REST endpoints. But again, the same things that we discussed with this application would apply, for example, for an application where you decide to implement your front end using a JavaScript library or a JavaScript framework such as React or Angular. So mind that what we discuss here is really important for any kind of application where you have a front end calling a specific backend. So you will see immediately when you will actually understand what this vulnerability is and how does the protection against it work in Spring Security, you will basically understand that this relies to the basics of any kind of web app. So for the moment, for our example, I need to create this controller which will apply the normal Spring MVC flow, and of course I do need an action for my page. And that will be, I don't know, we can call it main, so I don't really care that much how the method is named, and it will be a simple get mapping, and I will return the physical view name, which in my case will be, let's say, main HTML, so HTML, and that should actually be a page in my case. And because I'm actually using a templating engine, I will create this page inside the templates folder in my resources folder of the Spring Boot project. You can see my structure here. So I have created the controller, and then now in the templates, I will create this HTML file. And I will name it main, so this will be my main HTML file, and for the moment the only thing I need here is something to show me that I have reached this page, so to show me when I have actually reached this page. Is it a good practice to add API to API path? Yes, the question, I wouldn't say is not a good practice. It helps you actually to apply easier sometimes the authorization rules, because when you apply authorization rules, sometimes you want to apply specific authorization rules to specific let me not say pages, endpoints in general. So when you say /API, then you have the opportunity to actually say /API/**, which with an unsyntax would actually mean that you refer to everything that is behind /API. So yes, it's a good practice to do that. It's actually not needed necessarily, you don't necessarily need to do that, but you can do that, and it helps you sometimes, again, applying your authorization rules. So yeah, I would say it can be considered a good practice for this reason. So I hope this answers your question, but I have no APIs here. So here in my case, I really have no APIs. I have only a page, so that's why I only rely on my page. I have just a very, very simple application with a main page, and automatically the logging form will be applied when I start my application. So let's see what happens. I have created my page here, and I have my controller here, and I have nothing configured in Spring Security, so I will just here rely on the absolutely default Spring Security configuration. It's actually the Spring Boot configuration for Spring Security, and when I run my application, then automatically I have now a user details service, I have a password encoder, and I have the username user with a password that will be automatically generated in my console. So when I run the application now, you should see in the console that unique identifier representing the generated password that I can use. So I wait my application to start, and at some point we shall see the password, the default password. You see the default password here. Okay, I will copy this default password because I will need it for logging into my application, and you can see that my application successfully started in 8 seconds. And I can now go back to a browser where I will basically try to access my application. So I will try to access the main page, but of course I will be automatically redirected to a form. And that's the default form that will be automatically configured by Spring Security in this case, as you probably know from our first lesson. So it is a good practice to add static to attribute final, like private static final X repository. Well, for sure, no. That's something I can tell you. You will never declare static repositories like static variables inside a class. Be very careful to understand what static is in Java. When you declare something static, it is no longer part of the object, and that means that the variable is there from the beginning, so from when the class loader loads the class in which you declare the static field. and doing so, it means that you have only one variable of that type and it's unrelated to the instance, while when using dependency injection with Spring and with any other dependency injection and context related framework, we rely on instances, because that's why that's what we have in the context, and that's what we inject. So no, never ever use a static field in a bin, never ever declare a static repository in your application. So I hope that answers your question. But if you have more questions related to static, what static is and isn't, I have there already recorded a lot of lessons in the Java fundamentals stream, and one of them is related to how static works. And understanding how static works will also clarify you why you shouldn't use it in such situations. So again, no, don't declare static fields in bins in Spring. In generally a lot of cases it won't even work, so you can try it, but it won't even work. And yeah, that's actually my answer to your question. So we can have a separate discussion about that if you want me to clarify even more, but let's now continue with our lesson. So I was actually here calling my main method, I was redirected to login. That's what I was expecting to happen. So I can now try to log in using the the pasted password that I have previously copied, and I sign in, and then I get to my main page, and that's basically it, and nothing special about it. So let's log out, because you have seen now the flow. It's been nice, it's working, but you probably knew already that from the beginning. What I wanted to show you, it's actually, and going here, I will enter my developer console here in Chrome, and I will access the elements so that I can see the HTML behind this page. So what you will basically see in the HTML behind this page is that of course I have a form here. You can observe the form. I have the two fields in the button, and when I go even deeper into my form, one of the things that you will notice is that besides the fields and the button, I actually have an input hidden form here that is named CSRF, and that has a nice token value, strange token value, maybe you will think. So that's basically what we call the CSRF token. So if you wouldn't have this in your form, because when you press this button, we trigger a post action here. So when we trigger the post action here, by default Spring Security needs to have a CSRF token that it previously generated, and I will explain this in detail now, but for the moment I want to show you that we have this token, and then I will clarify what this token is and how this token works. So let's see now what happens if I disable the CSRF protection. So I can disable the CSRF protection, yes, and that's one of the main things, one of the main mistakes a lot of developers do. They do disable the CSRF protection when they should have it enabled, and I've seen that in a lot of projects. Or well, I've seen a lot of mistakes with Spring Security in a lot of projects for which I do consultancy, but let's say one of the mistakes is just disabling CSRF because they have observed, yes, post and put or delete doesn't work. And yes, it doesn't work if you don't use it properly with CSRF, and I will explain immediately why. But let's show you how first that you can disable it, so that you are aware it can be actually disabled if you don't need it. And to disable CSRF, then you would create, of course, I would need a project config, a configuration class. Let's call it project config, and I have to annotate it with configuration. And then I need to extend the web security configurer adapter. In this, I would override the configure method. Of course, here I will call the super method so that I still have that nice login form. But besides this, I will call CSRF, and then I will call disable. And if I do something like this, this disables the CSRF protection generally. Never I would say never, generally don't do this. Okay, smiley face. So generally don't do this. So I'm just showing you now that disabling the CSRF protection will automatically make that field disappear, and then I will start from an for an application where the CSRF is disabled, and I will show you how is it vulnerable. I will show you how an attacker can use the fact that you have disabled the CSRF protection to do something maliciously with your application. And then when we do that and we see that this CSRF is a really heavy thing, we will reapply the CSRF protection, and then you will see that the vulnerability doesn't work anymore. And then we will work a little bit more on configuring it and understanding how it works behind, because you really need to understand how this works behind in Spring Security if you want to customize it. So when you want to customize something, be very sure that you understand how that something works before trying to customize it. That's a thumb rule for anything, not necessarily only for CSRF or for Spring Security. In general, for everything, for any kind of framework, before trying to go into customizations, make sure you understand how that works. Is from my experience, I can tell you that's a rule of thumb, and you should always respect it. So let's see what happened now. I have restarted my application, I still have Spring Security, and I still have my default user detail service. By the way, if you don't know how and why this password is generated here, you should go back to the first lesson of this stream, because that's where I explained that. So mind that we discuss now is lesson number 9, so we discuss it after a lot of things we have happened in the past 8 lessons. So I'm now relying on the fact that you know what this password is and what the user detail service is and so on. So that's why I'm going so fast over it. So if you don't know what these are, it's an entire stream out there where I have discussed all these things, so you can just retake the recorded videos and understand these things I don't explain now in this video. Okay, so I have copied this and I'm going back to my application. Again, I try to call it, and you will see here now, of course, the button is the only one, and I have no input field anymore. So I have no input hidden field holding a CSRF token, because what I've done is I have just disabled the CSRF token. And of course, it will basically work the same as previously in terms of functionality, but it doesn't have that CSRF token, and the CSRF protection, which was enabled by default in Spring Security, doesn't apply anymore. So why you shouldn't do this? Well, how does CSRF work? Well, at the moment, if I have a post application, or a delete, or a put, or any other action, which we usually use for mutating actions, let's do one of our own in our application. So you can do that like in your main. Here I will make a simple do something action that can be called using post in my case. So you know that we use post or put or delete usually for mutating actions in REST. Okay, so I now call my post. I can even add a /change here, so you can see that it does a change. Okay, and I will go to my back to my only main HTML file. This is the only file I have, so I'm going back to it when I'm calling the post, but I will also system out something in the console, so you can see that I have actually called this method. And again, here in my case, what I will do, I will create a form, a simple HTML form, okay, and inside it I will have a simple button. So I have a button, press me, and I make sure that the form method is post, and I make sure that the action is /change. Okay, and I will make this type submit, of course. So that's basically it. you only have a button, you press the button, you call the action. Let's restart it, let's see what happens. So theoretically I expect now this button will be there somewhere under the hello word on my main page. I press it, I will see in the console the sad face, and I will tell you immediately why it's a sad face and not a smiley face, of course. So can you please upload the project for us later? Yes, I do always upload my projects on my GitHub account. So if you will look for any of the videos I have on this YouTube, in the comments and in the details, you will find the link for that specific project of the video. So yes, I will upload the project on my same GitHub account I use for all the videos. You will have it in the comment section and in the edited after I finish the live event. Thank you very much for asking. So you see what I'm doing here. Yes, I am just going back to the login. I need again the password. Maybe it was easier to actually really create a user details service here than rely on this. I thought it's easier to rely on this, but yeah, now it's too late. Let's use the default. I've copied the password. I do login. I have the press me. I press the press me. I'm back in the page, and inside the console you see the sad face. I have the sad face. That means it really called my endpoint here, which is something again we expected. Now look what happens. An attacker will send you an email with a simple HTML. It doesn't need anything specifically. It doesn't need any kind of special language, doesn't even need JavaScript for that. It does only need to have some HTML. Let me create some HTML for you right precisely in this project, because I will upload it again after I finish. So this is the project I'm working on here in my on my local computer, and here, just here, I will create a new come on. Oh my god, the computer is so slow. I'm not sure why. New text document, and I will call this malicious HTML. So this HTML is what you will receive through an email, maybe, I don't know, you will click on a specific site, whatever you want to imagine. Somehow imagine the attacker sends you this HTML. The easiest is probably an email, where you have an email and you have a nice image, and here is where I will put a form. So I'm going back here to my main, and I will take only this form from here, only this form, and I will put it here in my HTML file I'm creating. And of course, in my case, I can't now only call /change because I'm not inside an application, but I can call /change of that specific URL, which in my case is localhost 8080. And yes, this in this case is localhost because we are only working on an example, but in a real world scenario that will be, I don't know, it would be example.com, for example, or whatever your URL for your website is. So imagine this is your website here, and what happens with this simple form I have created in my malicious HTML, where I've put it in an email. Instead of having a button, I will just use a nice image or something the user will click on, and then when the user clicks on that, now it's still a button because I don't lose time to do nice interfaces, but in general the attacker will of course create you a nice interface, and we will somehow convince you, will persuade you, click on that, like in my case, and I click on this, and when I click on this I'm back into my page because being that I have logged in previously, when I have now pressed that link, the attacker forced me to do an action I didn't want to do. I was thinking that I was pressing a picture to go to a specific video, or I was thinking that I was going to download something that I needed, an archive or something like this. But instead of that, I have clicked the picture, or I have clicked that link, and the attacker persuaded me do an action in my application. And imagine that this action being a post or a delete. What does that mean actually? Well, it actually means I could have deleted some accounts in my application. I could have changed something in my data. I could have done something that I really didn't want to do. So this is a way in which an attacker could persuade us do some actions that we don't want to do. And if we don't have CSRF protection, like in my case here, you saw immediately what happened. I have clicked that button which was external to my application, and that made me do an action that I didn't want to do. And you can see I really did it, because you can see the set phase here, a second set phase appeared. So that second set phase appeared when I have clicked the button in my malicious HTML page, which simulated the email I would have received from an attacker that wanted me to trigger a post action that would change data even if I wouldn't want it to happen. So that's how CSRF work. The attacker forces me, persuade me, click on a link or something in that they send somehow, like an email or something, and when I click it, then this redirects to my application, and being that I'm already logged into the application, it forces me do an action, or it tricks me, not forces, but it tricks me actually, do an action that I didn't want to do, like deleting something in the application or changing something that I can't undo. So you see, it's a really simple vulnerability. It can be exploited by a very simple way of attacking the application, but it can do a lot of harm, because if this post here would have changed something dramatically, then I would have actually changed that by clicking on a link on an email that I have received, and I have being persuaded to click somehow. So that's really strong, that's really heavy, and that's why you don't want this to happen to your application. That's why we need CSRF protection. So fortunately, Spring Security, this is how I have disabled it, but if I wouldn't have written this line, fortunately Spring Security came with CSRF protection by default. So that means that I don't have to do anything, and I will have that CSRF protection, which works in the following way. When I do a get, and it's actually a do a get, a trace, an options, and the head, I think, are the 4 HTTP actions that I could do, and for which I don't need to specify anything special. When I did load my page, then Spring Security generates for me a token. This token is something that I shouldn't be able to guess, so it's something random, enough random that I am not able to guess. And you have seen this token. It was the token I have shown you at the beginning of this lesson, the token you have seen when I have opened the login page. So you see I have commented out this line now, and look what happens. I do restart the application, and I will access it from my browser. And you will see that automatically in the login form I have the token again, and that's why I can do the login. But do you think my action, my form, my button, press me in the application will actually work anymore? Well, the answer is no. Look here, I will copy the password again, and I'm going back to my browser, and I'm refreshing this page, going to main page. And I'm redirected, of course, to the login, and you can see I again have this CSRF token. And because of this token, I can actually do the login. Because what happened here, when I have requested via the browser address bar, I have requested the main page, and I'm redirected back, Spring Security generated the token and sent me the token in the body of the response. And what does now Spring Security ask for me to be able to do a post, put, or delete operation, or any kind of mutating operation, where it asks me for this value? It says something like, you don't have this value, you can't call any kind of mutating action. So I have given you, when you have requested the page, I have given you a value. If you are not the one to whom I have given the value, then you can't call any mutating operation. So in my case, login uses this value to show, to authenticate in Spring Security and prove that this is the browser that requested initially the page and received the response delivered. So that's why I will be able to log in. But inside my page where I have the form I have created, I have no CSRF token because it's my duty to edit. For the login page, it was a page generated by Spring Security. So Spring Security took the responsibility to create the proper way of me calling it, that is, took the responsibility of adding the CSRF token there. But in this case, Spring Security will do nothing. It's my duty. It's my form. It's my duty to make it work. And if I press the button here, it won't work. Because being that I didn't add the CSRF token there, I didn't authenticate to Spring Security to prove that I am the one who actually called the page. So I really need to use the token in this case for any kind of mutating operation, like a post in my case, the post, the put, the delete, any kind of mutating HTTP operation needs to be proved with a CSRF token. And if I don't add the CSRF token, then I will get a 403 forbidden in response. And of course, you will see that the set phrase doesn't appear because the action wasn't called. So if I want to make this work, I really have to take that CSRF token and put it in the request, in the post request, to make it work. Because by the CSRF token, I will prove that indeed I am the page to whom the response was returned initially. So client makes a request to the server, server generates a token that nobody else can guess, and returns the token in the response. Now only this client that received the token can do the post action. So when I will call it from my malicious page, being the attacker, we will have to create an outside page. So we don't have the token. So being that we don't have the token, we won't be able to reproduce anymore the attack, the previous attack. So for me to work, let's first make our form work. That should be pretty easy. I have to add an input hidden, like in the case of the login page. I do add an input, type hidden. Then I have a specific name for it and the specific value. And I know that the name is actually by default CSRF. But if you don't actually want to rely on the name, because as I will show you when we discuss the customization of the token, this can be changed. Then if you want to simply rely on any kind of value, the developer decides, on the backend developer decides to use here, then you can use the parameter name. And what I will do, that's the reason for why I use timeleaf here. I will actually use the timeleaf templating here to take the values easier, because otherwise I would have to, I can use some other kind of technologies, but it's much more difficult. Like if I would have used the JSP or something, or if we would have done through the REST, I would have used Postman, and it was much more difficult. So what I'm doing, I'm using this nice templating engine, which saves a lot of time for me, and then I can hopefully do something like this. And then instead of writing the value directly here, I can take the value from the request by using the name of the attribute, which is CSRF always. So CSRF, and then I say parameter name. And this is the parameter name, the attribute name on the request on which Spring Security will generate the token. And then the same thing, I should be able to do the same thing here. I can put them like this to be easier to see. And I say th value, and then here is the token. And you will recognize this too when we discuss the customization of the CSRF token. So maybe now they look strange to you, but they will be very familiar when you will see how Spring Security represents the CSRF token. So for the moment, take only them as they are, and you will only understand for the moment that this adds the token to my request. And because I add the token value, the correct token value to the request, I will be able to do the post action. and then you will see where they are coming from, because the next thing after we prove the attack doesn't work anymore, the next thing we do is discussing the customization. So I will rerun my application. And yes, I still need the password, and I'm going back here and I will restart everything. I'm in the login. You see the login, you see the input hidden that Spring Security added by default here, and I do use the user and the password, sign in, and then what you see in the form, that is basically very similar to what you have seen in the login form. So this input and the value of the token automatically appeared here. It's a hidden input, you don't see it on the page, but being that it will be part of the request, see the name was automatically taken, the value was taken from the response, you can now do the action, but with the CSRF protection enabled. You see the sad face appeared again, but now we know that for sure it was us doing the action, and the user cannot be tricked into simply pressing a link in an email and that action could be done for him. Because when I now, let's say I'm going back, I'm again the hacker, I'm again the attacker, I want to do the same attack, the CSRF, to exploit the CSRF vulnerability of this page. And you know now that I have no more CSRF vulnerability, because when I'm going here, yes, I still have the possibility to trigger the user doing this request, this post request for me, but I don't have the possibility to add a token here, because I can't know which will be the value of the token, because only the response that is generated upon a request will be able to generate a token. So only the user itself will have that value and they will be able to do that. So if I'm now trying with what I have, because I can't add a token, and that means I'm just again opening my malicious page and I'm pressing the button. From outside, I will still get the 403. So this is how the attacker now cannot exploit CSRF anymore. So even though an attacker would try to force me click a link in an email and do some action I didn't want to do, like some malicious actions, some changes in the data of the application, they won't be able to do that, because they don't have the token, the valid token in the request, and they can't get the token because the token is only got by the browser of the user upon the GET request. So that's how CSRF protection works. So you have seen in this video, you have seen how previously when I disabled the CSRF protection, I was able to simply have an external page, which you can imagine is part of an email. The user clicks that and they do some malicious, they do some action that they didn't want to do, being triggered by some malicious attacker into doing that action. And now the attacker can't do that anymore because they need a token they don't have. So that's it. That's how it works. Pretty easy, isn't it? So CSRF is not that difficult at all. It only relies on having a token that only the requester of the page has. So being that only the requester of the page has the token, only the requester of the page can do mutating actions. So that's something you should always be careful your application has. Be careful your application doesn't have such a vulnerability where somebody can trigger the user into doing unwanted actions, and maybe by that deleting or manipulating data on a specific user's behalf. Cool. Now that you have understood that you have understood this, we can discuss further about how the mechanism in Spring Security is implemented, because if you would like to customize it, you need to understand how the mechanism works. So yeah, I'm back to my project here, and of course, if you want to customize the CSRF, then you can customize it in the configuration class. And see, you have in the HTTP the CSRF, but we won't of course disable it, so we don't disable it, we leave it as it is, we leave it enabled. But now you can use a configurator for this, which you very simply do like this. So we have a question: even being visible only in that web page, it is possible that hidden input with CSRF value to be also intercepted by a hacker. Yes, theoretically a man-in-the-middle attack will be able to intercept that, and then in this case you would assume we have the situation like this. So we have a man in the middle, the attacker intercepts somehow the response. Usually we use HTTPS, so the attacker should also do somehow like being able to get that value in spite of fact that we use HTTPS. But let's assume they manage to do that. They get the CSRF token, and then if they have the token, they still have with that token to somehow persuade the user to click on a link. So it's a little bit difficult to consider all of this is possible. Like you get the token, you do a lot of things to get a token, you need to be in the middle to pass over HTTPS, get somehow the token, and then with the token you still can't do a lot, you still have to now fool the user, press on the link. Maybe it's possible, so there is a chance that someone can do that, but you can see from the scenario that the chance is much more minimal than in a normal case. So it's very minimal to be in this scenario where you man in the middle it, you get the value, and then with that value you persuade the user click the token. Being that anyway the token changes with the next request, that means that you have a short-lived time in which you have to do that anyway. So it's very difficult to do that. It's possible, there is a chance, but really difficult to do that now. I hope this answers your question, Cosmin. So yes, now you can customize it. You use a customizer, and this is a customizer. You can use it as a lambda expression because it's an interface having only one method, so that's pretty easy to use it. You can see the customizer is this interface that the CSRF method receives, and this customizer has only the customize method. That's why I'm able to use it with this nice lambda expression. If you do a lot of customizations, then I do recommend you take it out, so don't do it all inside one method. Try to decouple your configurations, but in our case I will make it shorter like this. One of the things you can customize, and you might need it at some point, and the simplest customization maybe is to use the ignoring matchers to just ignore the CSRF protection only for some endpoints. So CSRF protection is needed in general, but as any other framework, Spring Security allows you a highly way to customize your behavior. So let's say we have a chance in which you need to have an endpoint that is for which the CSRF protection is disabled. You can do that by using either the ignoring ant matchers. So for example, I can do something like this. I'll say CSRF disabled, and then if I have this prefix CSRF disabled, anything under this prefix now will be automatically for those endpoints the CSRF will be disabled. So if you need something like this, you can disable the CSRF protection for specific endpoints by using ant syntaxes, or by using, as I've said, request matchers, which allow you to use MVC matchers, or regex. Regex, in the very case in which nothing else can save you, you can use regex. Of course, I've never used it in a real scenario, but Spring Security offers you the highly customizable possibility to even use regex if you want to do that. Okay, I have another question. Thank you for the question. Is the CSRF token short-lived? Yes, it is short-lived. So in the case in the man in the middle attack, as I just previously explained, if let's say the man in the middle, the hacker, would really manage to get the token, and they still have to fool you to use the token, the token can be only used until the next token is generated in the default way. The Spring Security works with generating tokens that I will now explain you, and you will see that you can even create your own mechanism for tokens, but anyway the token is short-lived, so that means that the attacker, even if they intercept the token, they will still have a very short time to fool you into clicking a link, and by that doing some actions you don't want to do. So you see, it's much more difficult. You can never say it's not possible. Security vulnerabilities always exist, but our purpose, our target is to minimize them as much as possible, and the CSRF token protection is generally enough. We consider it enough to protect applications against these kinds of attacks. So it's a really good way to protect the applications against the CSRF attacks. Okay, but again, if you need to disable it for specific endpoints, you can use ANT, MVC, or even regex matchers. So that's one of the easiest things you can configure with your CSRF protection. The much more difficult thing, but not necessarily very difficult, I just used the word difficult, but it's more difficult than just ignoring the CSRF protection for some endpoints. You can customize your entire CSRF token mechanism. So you can do that. You have by default the provided Spring Security mechanism, which relies on the session ID. So the way it works now, if I use it as you see me now using it in Spring Security, what does the mechanism behind it do? It actually generates some unique identifiers. You have seen them, and they are attached to a session. So when the request is done, the mechanism looks in the session, they find the session ID, they find the token, they match the token to see that it's fine, that is the correct value, and then they approve the request. Or if they don't find the token, or they find a wrong token or a wrong value, then of course the request is rejected. And you see that nice 403 forbidden HTTP status of your response. But if you want to have something different, if you want to implement something different, you can customize this CSRF mechanism, and you can do this by using the customizer. And the way it works, the point, let's say the point of start is this CSRF token repository, which is a very nice interface with 3 methods that represents most of your let's say CSRF management. So this CSRF token repository is basically what you want to create to have a custom way of managing your CSRF tokens. So let's see what the CSRF token repository, I think it should be in the classes already here. Repository, of course, I have to correctly write it. So this interface, which is the contract representing, let's say, the object managing your CSRF tokens in Spring Security, have 3 methods. The one that you use to generate the token, the one that you use to save the token somehow, because in order to be then checked when the mutating request comes, it has to be saved somewhere. By default it's in memory, but maybe you want to decide to save it in a database. I don't know, maybe you want to implement for some reason another mechanism. Then you will have to provide a way to generate the token, a way to save the token, and a way to load, of course, the saved token, so that the framework can validate what was saved with what was received. So it's pretty easy actually. This is the responsibility of the token repository, which implement basically the mechanism itself. When I say the mechanism, you don't need to, the mechanism itself, if you think about it as the ifs and else, those you will probably never need to modify. But you can alter it by altering these 3 functionalities: the way you generate the token, the way you save the token, the way you load the token. So if you want to create, and I can show you how to do that. If you want to create your custom your custom CSRF token repository object, that's pretty easy. Just have to create a class, custom CSRF token repository. You will have to implement the CSRF token repository, of course, and then you will have to override the 3 methods and provide the functionality that you desire. So your implementation, you have to provide the way how the token is generated, a way the token is saved somewhere, a way the token is loaded. So now you see actually how the token is represented. That's one other nice aspect you would like to remember. This CSRF token is another interface that represents the way the Spring Security understands the token itself. You can create your own implementation, whether this is actually really not needed, because you only have 3 methods here providing the token, the parameter name for which the value of the token is stored on the request, and the header name on the on the response, the attribute name of the response, and the header name on the new request where the mechanism expects to find the value for validation. So this is what Spring Security needs from a token. And that's why, because I'm going back now to my template, the HTML template, that's why I told you this would make much more sense now. You will see that basically parameter name and token, I was able to take them like this because this is the attribute, and this parameter name, and this attribute is actually of type CSRF token, okay? Because this is how Spring Security represents the token. So parameter name is this parameter name, and token is the value of the token, which is the token here. So you see why I was actually able with time lift to refer to them like this. I have referred to them like this because this is the way Spring Security actually stores the token. So they have this, and this to which I can refer. And in my case, I only needed to know, of course, the parameter name and the token. So again, you can create your own implementation, but usually you will use this default CSRF token, which is everything you need. It's like a POJO implementing this contract and allowing you to store the values. So we can do something like this here to prove you how it works. We can say something like CSRF token T new default CSRF token, and then I provide those values that I need. I can use the header name, which will be like this, parameter name, sorry, it was the other way around, so it's header name, but anyway, it's a custom one, so it doesn't matter. Like, I don't know, CSRF token, let's say, is the header name, and then of course I need to add the value of the token. That's the one most interesting for our example here, the value. Let's say I do always generate the same value, 1 to 9. This is really easy now to see. If I do use my token repository, you will always see this token 1 to 9. I think it's clear because I don't generate it randomly. This is just an example for you, okay? Okay, so this is just an example for you to understand how this works. So I'm creating the new custom CSRF token repository. I have it here. I won't implement these 2 methods anymore. I just want to prove you that it works, and of course then you will find a natural way to doing it, because otherwise you will never have always a static value. Otherwise it doesn't make sense, okay? You have to have here a value that is not easy to anticipate. It has to be as random as possible. But in my case, it's really useful that I make it static, because now I have restarted the application. I have configured this custom token repository, and guess what? When I call the application again, the token is precisely the one with my value. So have you seen how I actually managed to create my own token management? It's pretty easy. You just need to implement an interface and to tell Spring Security how to generate the token, save it, and load it when it needed it. So you see now my implementation is used because you see the value of the token is always 1 to 9. So now I will of course comment this out because I I don't want this kind of a token, otherwise I have no protection. And is there something else that we have to discuss actually about CSRF? I think we have covered the most of the things about how this works now. It should be the main things. I'm just looking to make sure that I didn't skip anything, but we discussed about how to ignore it. We discussed about how to create your own CSRF implementation. You have seen how the token is represented using the CSRF token. You have understood now why I was able to use this as well. You have seen the attack itself, how it's done. So basically this is it. So this is the CSRF. So you know now how we've started on how to disable it. You have seen why you shouldn't disable it. We have managed to do the attack on our own application by using a separate page. We have enabled it. We have seen that the attack doesn't work anymore. Then we have seen how it works behind. I didn't mention that it is a filter in the filter chain. Maybe that was important to mention as well. So it is a filter in the filter chain that triggers all the protection. By the way, it's called CSRF filter. So if you want to see it, you can even do a filter to log the token itself. So you can do something like CSRF logger, token logger. Let's call it token logger filter. You know how to work with filters from one of our previous lessons. So you see, we do like how can I call it? Yeah, I won't use the filter interface. I will use the once per request filter basically because it's easier. So did you mention under what condition would disable this feature? Very good question. 10 points for Gryffindor. Thank you very much for asking that. So yes, I didn't specify when shouldn't we use CSRF. Where there is, we encounter situations in which CSRF protection shouldn't be applied. Now, I'm not precisely sure if you ever would need to use ignoring ad matches. This is only a feature. I've never used this in a real world scenario, but an answer to your question would be why shouldn't an application have CSRF at all? Is there a case in which we don't want to have at all this CSRF feature? Well, yes. Basically, we have situations, we have architectures in which it doesn't make sense to have CSRF. And one of these architectures is the OAuth 2 architecture that we will discuss in one of our very, very close future lessons of this stream. Because OAuth works differently, completely differently, it works using their own tokens in the implementation. And because of the way it works and the tokens it uses, the way it uses the tokens there, you don't need to have also CSRF together with an OAuth 2 implementation. So it doesn't make sense to have both of them all together in that case, in a part, at least a part of the system. But I will need to get to that point in OAuth 2 to precisely explain how CSRF works and where it doesn't work with OAuth 2, and that will be in one of the very close future lessons of this stream. And basically that's the most known and encountered case in which you won't have CSRF. If that's not your case, you will mainly, and I do recommend to leave it enabled. And I have seen a lot of situations again in which developers simply disabled it because maybe they didn't know what this is. But now you know what this is, and you know why in a real world application you need to have CSRF. Otherwise, what happened in our lesson at the beginning, when I have created the separate page and I have managed to trick the user into clicking the button and creating doing an action, making an action they didn't want to do, that could happen in your real world scenario as well. So in most of the cases, use CSRF. I would say in general, in any case, you would like to make sure that the front end that loaded the response is the only one making the mutating actions, in all these situations you should use and you should have CSRF protection enabled. Okay. And the last thing I want to show you, and I have a couple of minutes for that, is how this works from the beginning. I didn't mention that there is a filter in the filter chain. The filter chain is something that I have explained in one of the previous lessons of this stream. It's a very important part of the Spring Security basic architecture. So if you didn't see that lesson, you might want to see it, and it's there somewhere on the same channel. You can find it, and you can see how the filters work. I can add my own custom filter. I will use, in this case, to make it simple, I will just use the once per request filter class, and I will override the do filter internal here. Let's call this request to make it shorter, and response. And of course, this is the filter chain. At some point I need to use the filter chain to delegate the request further in the chain using the do filter with request and response. And what I want to do here, I will take the CSRF token, no, just the token I want. Okay, this is the token, perfectly. And I will take it from the request get attribute CSRF. So you will see by this, you will actually see that I can take from the request the attribute as the token, and I can print it out in the console. And I want the token value, and you know the token value will be, I can get it using the get token method. If I add this filter just after the CSRF filter, the CSRF filter is the place where this is applied, so where the token is generated. So the token will be generated, and then if I add this filter just after the CSRF, I expect to see the value in the console, because that's where the token is generated, and then it's added on the request, from where, for example, I can take it here from the time leaf and use it in my page. So that's why I was able to use it, because the filter in the filter chain already added this token. So to prove that I can use filters as you have already seen in one of the previous lessons. So I do add a filter after, I want it to be after, so I say this is my filter, and then I want it to be after CSRF filter is the name of the filter taking care of this CSRF protection in Spring Security. So if I do add a filter, my filter like this, after the CSRF, so it's after the CSRF filter will generate the token, my filter will print it in the console. And that's how you can see, you can imagine now from the beginning, from the request, how the CSRF filter now intercepts the request, applies everything, and then the request is forwarded in the chain, and I either get to the functionality by my call that worked because I have properly used the correct CSRF token, or I simply get rejected with a 403 forbidden. So last thing, going back here, I'm calling the page, and I'm going to the console, and here it is. This is the token. So this one was printed by my filter here, by this filter here. And it was printed because I have placed this filter immediately after the CSRF token in the filter chain. So you can imagine the filter chain, I have a lot of filters. Somewhere is the CSRF token, the CSRF filter that takes care of all these mechanisms, and then I have placed my own after. So the CSRF filter generates the token, and then my filter, my custom filter here that I have added after the CSRF filter can find the attribute on the request and I can take the token, and this is exactly what I'm doing here. Is precisely what TimeLeaf is doing here when it's taking from this same attribute the token. So you see how I'm taking from this attribute the token. Same happens in my page where TimeLeaf took the token value from the CSRF attribute. Okay, so basically this is how CSRF works, and I have at least covered the basics, even more than the basics. I think it's almost anything that is very probable that you will find in real world scenarios. So I hope you liked it. Thank you very much for being here with me. Hope to see you for the next lessons, because we have still to work a lot more on Spring Security and a lot more on how to implement security in your Spring applications, and not only. Have a great time for study. Until next time we meet. Thank you very much.